Hello everyone, welcome you all in the video of tool life. In the previous video you have learned the tool wear means what. So this tool life and tool wears are two points related to each other. So this tool life includes, which are these point if you observe here. Tool life means what, tool wear, factors affecting on tool life, Taylor's tool life equation, and in the next video we are solving some problems on the Taylor's tool life equation. In the previous video the tool wear bit is covered, so now we'll go for the remaining points. Tool life means what, which are the factors that affect on tool life, and Taylor's tool life equation. So let us start with first. Tool life means what, actual machining between the two successive grinding of tool. We are calling it as a tool life. Tool life means what, we can define it as a time interval between the two successive grindings. During this life period tool will perform the work satisfactory, means what, it will cut efficiently and effectively. Now here tool cutting time means what, we are measuring the tool life in terms of time. So tool cutting time accumulated before the tool failure is called as a tool life, means what, in between the two successive grinding, means what may happen, the tool may fail, it will not work satisfactory, so that time between these two is called as a tool life. Also sometimes this tool life is defined as useful life which has been expended when it can be no longer produce satisfactory parts, means because of blunt of tool, surface finish may not be proper, forces required may be more, excessive temperature may be produced, like these parameters may be considered. For the mass production, number of pieces produced are the important, we know that, and for the rough production, how much material removal rate is there, that is the important. As just discussed, tool life means what, time interval. Now we'll discuss the factors affecting on tool life. Which are the factors these are influencing or affecting on the tool life? These are properties of workpiece material, second tool geometry, third parameters like speed, feed, depth of cut, tool material, and cutting fluid and temperature. So these are the parameters which are affecting on the tool life. First one, properties of workpiece material, whether that material is of ductile or brittle material, what is the hardness, strength, toughness, all these properties are affecting on the tool life. Means if material is hard, the forces required will be more and it will ultimately affect on the life of tool. If material is hard, the life of tool may goes on reducing, and if softer material, the tool will perform satisfactory and it can work satisfactory and life of tool will be the more. Tool geometry. In the single point cutting tool also we have discussed that geometry and nomenclature of single point cutting tool as well as for the multi-point cutting tool. So while preparing the tool, the geometry and nomenclature point of view, different angles, different parameters are considered. If with proper design the tool is prepared, then it can perform well, otherwise life of tool will be decreased. Again, speed, feed, and depth of cuts which affects on the life of tool. Tool material, different tool materials already we have discussed, that may be high carbon steel, diamonds, ceramics, like that materials we have discussed. So based on the cutting speed, sustainable temperature, the tool must be selected. Next, cutting fluid and temperature. So this comes under the machining condition. Because of continuous cutting operation, the temperature will be there in the chip, tool or workpiece. So excess heating should not be there. That care is taken. For that purpose, fluid or coolant is provided. Because of excess heating, the life of tool will be less, and if proper cutting operation will take place without excess temperature, then life of tool will be more. Taylor's tool life equation. To find out the tool life, we are studying here Taylor's tool life equation. So you'll observe here what is Taylor's tool life equation. Vt raised to n is equal to C. V is the cutting speed, T is the tool life, and C is the constant. Here you are observing n is the exponential component. So Vt raised to n is equal to C. From this equation we can find out the tool life T. That value will be in the minute. This cutting speed V is in terms of meter per minute. T is the tool life in minute. N is the exponent which depends on the cutting condition. Means what? That n value will be equal to 0.1 to 0.15 for the HSS tool, 0.2 to 0.4 for the tungsten carbide tool, and 0.4 to 0.6 for the ceramic tool. And this C is the constant, that is numerically equal to cutting speed, that gives the tool life of 1 minute. So these are the 4 terms used in the Taylor's tool life equation. Now from this equation we can say, if cutting speed is higher, then the tool life will be less or shorter. So higher cutting speed means shorter tool life, and vice versa. So in this video, this video consists of tool life means what, factors affecting on tool life, and Taylor's tool life equation. In the next video, the problems based on this tool life equation will be discussed.